Okay, so we're gonna start off here. In order to do this worksheet, guys, we're gonna be using this theorem right here. It's called the isosceles triangle theorem. Now, what this one says is if you have an isosceles triangle, now an isosceles triangle is a triangle that has two sides that are the same, two sides that are congruent. Right? Let me name this triangle. Let's see, we have triangle A, B, C. Okay, so this is an isosceles triangle, sorry, and we know that this side is congruent to this side, right? So two sides are congruent, two sides are the same. And what this theorem says, what the isosceles triangle theorem says, is if two sides of a triangle are congruent, that means that these angles right here are going to be congruent. So we have that this angle is congruent to this angle over here. So these two angles are the same. And this is a concept we're going to be using to answer these questions right here. Okay, so it says refer to the figure at the right. We're talking about this figure over here, and it says if line segment AC is congruent to line segment AD, name two congruent angles. Okay, so let's look at this here. We have segment AC. So AC would be right here. So segment AC. So that would be congruent with segment AD, which is right here. Okay, so now we can see that we're going to be using this big triangle, right? The one in red. And here they're telling us that these two sides are congruent. AC, so this side here, is congruent with AD, so this side right there. So what does that mean? Well, if we look at our theorem, it says that these two angles right here are going to be congruent. So if we translate over there, so we're just kind of going to rotate this triangle. We're going to see that this angle and this other angle are congruent, right? So there's two ways we can. Well, there's only one way you can name this angle. There's going to be angle ACD is congruent with angle ADC. Okay, so we're going to write that here. So we have angle ACD is congruent with angle ADC. Right? And we're talking about these two angles right there. So fairly simple, nothing too bad, nothing too hard, right? Let's go with the second question. Let me erase this. And now they're telling us if line segment BE is congruent to BC, again, name two congruent angles. So let's look at which segments they're telling us here. Look at segment BE. So BE would be right here. That segment right there. And segment BC. And this segment right. Okay. So we're looking at the smaller triangle that's actually inside. So this triangle right here. Triangle BCE. And here they told us that this side, BC, is congruent to BE. So what does that tell us? Well, we kind of going to rotate this triangle to figure it out. So that's going to tell us that this angle right here is congruent to this angle right there. So what angle is that? Well, we have angle BCE is congruent to angle BEC. So let's write that down. So angle BCE is congruent to angle BEC. Okay, again, very simple, nothing too complicated. Again, all this theorem says is if two sides of a triangle are congruent, that means the two angles are also going to be congruent right there. The next one we have if angle, now they're giving us the two angles. So here in the questions 1 and 2, they were giving us the line segments. Questions 3 and 4, they're giving us the angle. So we're going to use the opposite rule, right? So if two angles are congruent, that means that two sides of a triangle have to be congruent. Okay? So here we have angle EBA. Let me color code that. angle EBA, we're talking about EBA. Okay, so we're talking about this angle right here. EBA, we're talking about that angle right there. Is congruent to which other angle? To angle EAB. EAB. So EAB, we're talking about this angle right here. Okay, so those two angles are congruent. So what are going to be the sides that are congruent? If you look at them here, if we kind of rotate this triangle this way, right? We're going to see that these two sides are congruent. So AE is congruent to BE. So AE is congruent to BE. And we're going to write that down. So line segment AE is congruent to line segment BE. Again, this is really simple. All it's saying is if two angles are congruent, that means the two segments have to be congruent. Now the last one, very simple. We have angle CED. Angle CED. CED, so it's this angle right here. C, E, and D. It's this angle right here. To angle CDE. So CDE, it's going to be this angle right here. So what two segments are going to be congruent? What's actually very similar to this one? It's just rotate a tiny bit. So it's going to be these two segments right here, which are going to be these two segments right here. Segment CE and segment CD. And that's what we're going to write down here. So we have segment EC is congruent to segment CD. And that's how you do this portion here, right? Super easy, nothing too complicated. And just scroll up to do the bottom half. And I really hope this is recording right now. Okay, so we're gonna use the same thing, guys. We're gonna use the same theorem, so the same concept, right? If two sides are congruent, that means that two sides are gonna be congruent. The two angles, sorry, are gonna be congruent as well. Well, let's look at this. We have that this side segment, it's asking for the measurement of angle ABC. So ABC, it's asking for this measurement right there. How much is that measure right there? And some of you guys probably already saw it, but it's very simple. It says that this segment is congruent to this other segment. So if this one here measures, these two are going to be congruent. This measures 60, so that means that this other angle also has to measure 60. Like I said, easy peasy, lemon squeezy. Okay, let's look at number 6. So they're telling us that these two sides are congruent. So ED is congruent to EF, right? Those two sides are congruent, which means that these angles here have to be congruent. So this angle here is the same as that angle right there. Now we all know that when you add up all the angles of a triangle, it should give you 180 degrees, right? Well, they give us this number right there, which is 40. So what we're gonna do, we're gonna get 180, which is a total number. The total number of, when you add up all the angles, it should give you 180. And we're gonna subtract that 40 from there. So that's gonna leave us with 140. Okay, now that 140 is being divided by these two angles. Since they both measure the same, we're just gonna divide it by 2. So 140 divided by 2, that gives us 40, divide that by 2, that's 7, 0, Okay, so 70. So that means that each one of these angles measures 70. So angle EDF here measures 70 degrees. Okay, again, the concept is super easy, guys. And then finally 7 and 8. Find the value of each variable. So this is pretty simple. Okay, I can't see the bottom, so we're just doing number 8. But they're all very similar. So here they're telling us that this segment is congruent to this other segment, and we know that because it has this little line right there. So those lines mean that they are congruent. So what does that mean? Again, that means that this angle is congruent to that other angle. And so all we're gonna do is we're gonna set one more important thing. That angle right there, we know how much it measures. It actually measures 90 degrees. And how do we know that? It has that little square right there. So that right there measures 90 degrees. So we're gonna do something very similar to what we did on the top problem. So we're gonna get 180 minus 90 is 0, and it gives you 90. Okay, so again, we know that if we add up both of these, it should give you up to 90. So we're gonna do that, we're gonna divide that by 2. So we get 90 and divided by 2. Because we want 2 equal parts. That's gonna give you 4, 8, 1, and 45. That means that each of these angles here measures 45 degrees. Okay, and why do we care? Well, we're trying to look for x, so we know that this angle here measures 45, so we're gonna put 45 equals, and then you're gonna write that expression right there. So we have 2x plus 3. And now from here, you guys can just use the calculator, right? We go into menu, we go into algebra. You go into algebra, and then you press and solve. You're gonna type in this equation just the way you see it, and at the end you press comma x, press enter, and give you the answer. But you could also do it by hand. What we would do here, we just add 3 to both sides. Plus 3. Sorry, not plus 3. We do minus 3. Minus 3 on both sides. This cancels. Here we're left with 42 equals 2x. And then we just divide by 2. 42 divided by 2 gives you 21. So x equals 21. Easy peasy, lemon squeezy. Please behave, guys. Put this up. Thank you.